well, I want to introduce you a little bit the company that I belong to. As you can see here, Sorigué is a dynamic group of leading companies in the construction, services, technology, and water engineering sector with a clear commitment to innovate and improve society. Well, I can speak a little bit more about our company. This company was founded in 1954 and has its origins in manufacturing, aggregates, and asphalt treatment. That is to say, in extraction of different materials from a quarry. But throughout the years, the company has undergone a steady continuous growth, along with an increase in turnover, staff, and means of production, having as a result the opportunity to diversify in other areas. Okay, at the present, the group consists of around 35 companies and more than 4,000 people employees. And among other sectors, the group is involved in, for instance, services in terms of urban maintenance, transport, or landscape. Agriculture, we have different crops of fruits, almonds, and olives. Waste, well, we're working on the waste management in urban solid collection and other kind of wastes. Construction, well, doing civil works and edification for industry and public sector. Water, that I'll explain later. And materials, well, manufacturing, aggregates, asphalts, and also concrete. Well, that's our strategy is clearly focused on a circular economy, and the innovation department, which I am part of, is in charge of connecting them in a transversal way. Okay, that's, well, our strategies is clearly focused in these three strategic lines. As our main expertise comes from the water sector, where we are leader in design, construction, and operation of large-scale water treatment plants, mainly regarding wastewater, as well as hydraulic infrastructure more generally. I want to show you our strategy in this sector, which is divided mainly in three core points: energy efficiency, water reuse, waste transformation into added value products, or even in energy. Okay, well, although some of them are really well interconnected, that is to say, some projects are focusing on water reuse and energy efficiency, or energy efficiency during the transformation of wastes into added value products, or to use an added value product into water reuse, or in other way around giving us this circular scenario. Therefore, we are working in different cutting-edge technologies, in different water treatment R&D projects, mainly based on the use of nature-based solutions. For instance, my previous speaker, Clara, explained about those, and we are working with them into projects called electrowetland and water tour. Also, new disruptive desalination process when we are working in the Lowy project. New materials for wastewater tertiary treatment when we are working the Water Harmony project and Aqualox project that we are working together with ICFO, with this research institute. Also, revalorization of wastes from wastewater treatment plants for water advanced microbiology treatments for removing the pollution in wastewater to enhance the reuse. We are gonna start to collaborate with Eurecat in the project water mining that it starts in September of this year. And this is an European project, an H2020 project.
Beatriz.
Okay. Yes.
You have a pop-up in the middle of the screen. I suppose it's the list of participants. If you can move it till the corner, okay. Thank you, because it was covering some part. Thank you.
Thank you. Thank you. Okay. Well, all these projects, I want to puntualize that they are always focus on being more sustainable and more environmentally friendly. Okay, as I have a short time for my presentation, I want to focus on some of the different innovation projects that we have in our portfolio to just transfer you the idea, just an idea. Okay, well, let's start with a project from the energy efficiency line. This project is called Lowy Project, and it was started in the beginning of this year. This is a desalination project where the general objective is cope with water scarcity through the development of a new energy efficient desalination system to treat waters of different salinities, recovering 100% of water and reaching the desired discharge zero or zero liquid discharge. Sorigue, in collaboration with Tecnalia, will co-develop a system based on capacity deionization technology, uses as an electrode made of graphene to absorb the different salts. On the other hand, the German partnership formed by TINIT, that is an SME company from Germany, and the Technical University of Köln, will work on a desalination post-treatment technology consisting of a solar-powered thermal technology controlled by an intelligent self-learning process to reach this desired zero liquid discharge to get 100% of salt recovery and pure water for different applications, for instance, municipal, industrial, or for agriculture. Okay, first of all, we will test some trials at lab scale in order to transfer this knowledge to design and operate a pre-commercial pilot plan in real conditions. Well, the duration of this project is 2 years, and the call from we will receive the funding is Nucleus International, a program interlinked between Catalonia and Germany. And as well, for information, you can see here also the total funding that we received from our funding agency. Okay, well, the second one is the Water Harmony Project. This is an international project with 12 partners, where we are collaborating together with Leitat in order to develop innovative compact filters made of electrospoon nanofibers able to remove micropollutants to enhance water reuse. These filters have significantly higher water permeability than conventional membrane processes as tertiary treatment. Therefore, they require relatively low applied pressures and relatively low energy. These polymeric nanofibers are able to remove different micropollutants such as microplastics, antibiotics, pathogens, and pesticides, and the water produced will be used for agricultural purposes. First of all, we will design these filters at lab scale to test them and transfer the know-how to design and produce a real filter to test in a large scale wastewater treatment plant that we are managing. Well, as you can see here, this project comes from an international call that is called Waterworks, and the duration of this project is 3 years. And well, it started last year in 2019, and we have already had success designing a PAN and PVDF nanofiber at lab scale. And now we are trying to do some tests at lab scale in order to translate all this knowledge to a pilot scale. Okay. Well, the third and the last project is the project called Beyond Waste. This is a project from a circular economy Catalan government call that we are working together as well with Tecnalia. And it consists on transforming different wastes from the screening unit and the sludge line from different wastewater treatment plants into nanocellulose. By means of physicochemical treatments, first of all, for instance, using an oxidation as a pretreatment, and after that, different stages of rendering to obtain the final product, the desired nanofibers. These nanofibers, that they are made of cellulose, and this nanocellulose has high performances. For instance, in the paper industry and in the paint industry. And we want to apply all the knowledge that comes from this project, supporting this industrial world. Okay, the duration of this project is 2 years, as you can see here. Nowadays, we are trying to characterize the different composition of these wastes that comes from the wastewater treatment plants to see their cellulosic potential. Thank you very much. I think it was a short time, it was a short presentation, but I expect that you find the presentation interesting. And please, remember that Sorigué is always open to collaborate to innovative actions, for instance, working together in European Commission calls, such as H2020 or the new one, Horizon Europe, like projects, or Spanish or regional calls. Please don't hesitate and count on us. Thank you very much, and feel free to ask some questions. Please, I don't know if I have some questions.
Regarding the Water Harmony project, the question comes from Alicia. What will you do with the retentate? Is it possible to valorize the microplastics? On the other hand, how will you treat the concentrated emerging contaminants? Good question. Wow.
Okay, the first one, okay, we have those focus in this technology. The first one is to remove, that is mainly focused to remove pharmacs and pesticides, this kind of pollutants, thanks to advanced oxidation technology that we applied in these nanofibers. And the other strategy is to remove other pollutants like microplastics and to obtain a concentrate as well. The question was focused on the retentate. Our strategy is to do some backwash from these nanofibers, and with this concentrate, try to characterize them and try to, in other future projects, to know which is the best strategy to remove these microplastics or to oxidize. But this is not in the scope of this project nowadays.
Okay. Second question.
And the second question, please.
Is it possible to valorize the microplastics?
To valorize, as the name the name or the word is done. Microplastics is a low volume or a low concentration of plastics. Maybe a possible valorization is to go with this concentration to recycling I'm not sure about that because I'm not expert in this topic, but maybe one exit for these nanoplastics could be a kind of recycling of plastics, and in order to turn over the circular economy cycle.
Okay.
But I'm not expert, sorry.
No. The third question was, how will you treat the concentrated emerging contaminants?
The concentrated emerging contaminants. We want to remove these contaminants, these pharmacs and these pesticides, thanks to advanced oxidation processes. We are testing now some titanium oxide, for instance, in order to do some photocatalysis or remove these components into CO2 and water. And also we are testing argent, silver, in order to remove pathogens, because we know that the silver properties are really good biocides. For that reason, we need to remove these pathogens thanks to this technology.
Okay. Another question, Asma, I think she's from India. Have you tested the quality of the treated water? And do you know if it will have effects on vegetation after long-term use?
Well, this project is focused to design a technology as a tertiary treatment. We removed previously in the wastewater treatment plant all the organic matter and the rest of pollutants or this kind of micropollutants. We will try to remove the majority of them, and this water goes through the agriculture, but we have to take into account different legislation parameters like the salt content or heavy metals, for instance. And now we are just in the first year of the project, and nowadays we are not test. We don't produce nowadays water, but we think that at the final of the project we have like a manual to see what quality of this water we have and which kind of applications, not only in agriculture, maybe in other reuse applications, we apply this water. Okay.
Okay. Alfonso del Rey asks if nanocellulose is obtained from vegetal waste or from bacterial fermentation.
From vegetal waste. Well, I can show you the slides. Well, we would like to characterize the sieve wastes, and the sludge line wastes comes from a wastewater treatment plant. Also, in this kind of wastes, we can get some wet wipes or sanitary towels or diapers, for instance, and we want to characterize these wastes and to see the cellulosic potential of these wastes. And thanks to these techniques, these chemical treatments and these physical treatments, we can obtain, first of all, cellulose, and after that, nanocellulose.
Okay, another question from Gorka. He says, thank you, Beatriz, for the presentation. In the last project, how reliable is the nanocellulose obtention?
Well, we think that the limitant here is the first debris treatment from this waste. As you can see, this kind of waste, they are really, really dirt. They are plenty of organic matter, and we need to apply several chemical treatments, several oxidation treatments, in order to purify these wastes. And when we purify these wastes and we obtain this cellulose, this pure cellulose, we need to apply this physical treatment that, well, at the end is like a grinder, and to obtain the size, the switchable size for our final applications in these both industries, in paint industry and in paper industry.
Okay, from Elena Martinez from Atria Innovation. Thank you very much for the presentation. In the Water Harmony project, which is the minimum particle size that it is able to filter?
Well, this kind of filters acts as a micromembrane. Well, you know that we have some microfiltration, ultrafiltration, nanofiltration, and also reverse osmosis that you can remove all the salts. We are in the range of microfiltration. For that, our scope is to remove particles just above 0.1 microns.
Okay. Thank you very much, Beatriz. Many questions means very interesting presentation. Thank you for the high level again. And that's it.
Thank you.